lesson 61, 62, and 63. May take a little bit of time. I'll try to get through it quickly since you can replay this on Edmodo to watch. I want to start by reviewing just real quick a couple of lessons we've had before that we're throwing together into what we call a two-step problem solving. And we've had problems that look like this. Let me get it going here. Okay, we've had problems where x plus 4 equals 11, and we have solved those by doing the opposite operation as what's between the two. X plus 4 means we would need to subtract 4 from both sides. So x equaled 7 in that situation. And we have solved problems where we've had a variable with a coefficient with our variable, and let's say that's 16 equals 16. So we have multiplication between those two, and we've solved by either dividing by 4 or putting each of these over 1 and multiplying by the reciprocal. Okay, and that would leave us with x equals 4. What we're going to do is put those two steps together, and this can be a little bit complicated for some people at first, but if you get it straightened out, it shouldn't be real difficult. So starting off, we have 3x plus 2 equals 7. We want to, with these problems, I want to make this a little bit bigger so I can work with it here, and it'll be a little easier to see for you. All right, on these problems, I want you to think about this. There's our x, and we're looking at that 3 and x together create one term. So we're going to look at those as one part, and we want to get that part by itself. So if we were to think of this 3x as just being, say, x plus 2 equals 7, then what we would do to get that x by itself is subtract 2 from both sides. Okay? And so that's what we're going to do here. So our first step will be either to add or subtract some number away from this first term with the variable. So in this problem, subtract the 2 from both sides. That's supposed to be a subtraction. So this goes to 0, and we have 3x equals 5. That's our first step, is you're either adding or subtracting to get this term with your variable isolated by itself. Now you can tell by adding or subtracting the 2, now we just have 3x by itself. And we can solve for x then by dividing by 3 on both sides and getting that x is equal to 5/3. Or if you're someone that wants to do it the same every time, whether we have fractions or not, then we can write each of these whole numbers as a fraction by putting them over 1 and multiplying by the reciprocal of the coefficient, which is the fraction with your variable. 1/3, multiply 1/3. This all eliminates, which is what we want. And x equals, you multiply across, you can still get 5/3 either way. That's your second step. So you either adding or subtracting is your first step, and then either dividing or multiplying by the reciprocal is your second step. So first step, second step. Add and subtract. To solve for x, you're doing the opposite of your order of operation. Order of operation, we do PEMDAS, and where your addition and subtraction is the last step. Well, in solving, it's our first step, and then multiplication division is next. Now, that doesn't entirely hold true with exponents and parentheses stuff, so don't hold me to that exactly, but that's the idea with the addition and subtraction part. Now, the fraction makes it look a little more complicated, but it's still the same process. We want to isolate the term with x. So we want to get that part by itself. So our first step is to add or subtract, depending on what we have. We have a minus sign, so I'm going to add 1/2. Negative 1/2 plus 1/2 gives us 0, so I'm going to add 1/2 here. Okay. This all goes to 0. Get a common denominator. 6 is your common denominator. Take this one times 2, so that'd have to be 20. Bring down your 2/3 x. That's equal to, now I'm adding, so 20 plus 3 is 23/6. Step 1, first step. Adding or subtracting to get that term isolated. Now we want to multiply or divide. We're going to multiply by the reciprocal of the coefficient, 3/2. That'll get my x by itself, so I multiply this side by 3/2. Boom, boom, that all goes away. So you're left with x, and then your 3 and your 6 will reduce to 1 and 2, not 1 and 6. Now I can multiply across. 23 times 1 is 23. 2 times 2 is 4. Okay, so I wrote it down, but I didn't do it on this part. This is your second step. First step is either add or subtract, whatever needs to be done at this location. Second step is multiply or divide, whatever needs to be done at this point. Multiply by the reciprocal or divide by the whole number value, depending on the type of problem. Have one more example, mixed numbers. Don't get in a rush to think you have to get a common denominator for everything. Don't do that. I see people do it a lot, and it just makes for a lot of arithmetic. Just get common denominators on the parts you need. It's the same process, and the other thing is don't just get in a hurry and change everything to an improper fraction either. You can just, again, make more work than you need. We want to isolate the term with x. So we're going to either add or subtract. In this case, I have a subtraction sign, so I have to do the opposite. So I'm going to add 1 1/5 to both sides. Okay, and I don't want to get too complicated with it all here, but I want to show that I'm adding 1 1/5 to both sides. So this goes to 0, which is what I want. So I have the 2 1/3 x equals, I do now need a common denominator because I'm adding fractions here. Okay, so that part we need to get a common denominator. The common denominator is 10, so I'm going to simply rewrite this as, cancel this out here, and let's make it 1 2/10. That's multiplying both by 2. You get that. Now add across on that, you get the whole number of 1 is still going to be out front, and 25/10. Remember not to add the denominators. Ooh, that doesn't look right. That should be 2 1/3 x. We'll see if I can get it erased. If I need to rewrite it. Okay, one more time. All right, there we go. So this was 2 1/3 x. Okay, at this point, now we can change these into improper fractions because we need to multiply by the reciprocal. So here again, step 1, first step was here, adding or subtracting. Step 2, or your second step, is multiplying or dividing. Here we have to multiply by the reciprocal. So we got to get the improper fractions of 7/3 x equals 10 is 35/10 when we do that arithmetic. Now you multiply by the reciprocal of the coefficient, so 3/7, 3/7. This all goes away, so x equals, we can reduce our 7 and 35 to 5 and 1. That's, oh, and then we can go another step by taking the 5 and the 10, and that leaves us with 3/2. And these examples should be in the book. If you want to see them worked out in the book, replay this on Emoto, do what you need to do to go over them. But it's a two-step process. You either add or subtract first to get the term with x by itself, and then you multiply by the reciprocal or divide by the whole number value. Give those an honest effort. Try to learn how to do those. Okay. Took a little while longer than I thought, but we need to do that. All right. Lesson 62. These are pretty intense as well, and I'll go back over this with you hopefully when I get back so that we can get more comfortable with it. But I do want you to write this down in your notes. Everybody needs to have this in your notes. We've been talking about this f times of equals is from the problems that we've had where 2/3 of what number is 6/7. Problems like that. Well, now we're going to have word problems, and we need to be able to locate where to put certain ideas. So the F obviously stands for fraction. Okay, obviously a fraction. So that's the idea we're looking for in a word problem, putting a fraction there. The word of represents a number of different ideas. It's the total. It could be the beginning number, the original number, starting number. It's the first event in time. If you have two events, it's the first event in time. There are more that we'll add to this as we come to them. It seems like I should have a few more that we could put there. But I'm drawing a blank right now. I don't want to take a lot of time to do this, but you get the idea. It's the starting, beginning, original. It's what you have to begin with. All right, that's the number that goes in the of. The is the result. It is the part, or it's the second event in time. Okay, and if we come across some other things to put in here, then we'll add to it. Now here's probably the most important piece to this, and this is the part where if you can get this down, that'll help you to identify where to put things. Your fraction and your is have to represent the same item. Okay? Your fraction and your is have to represent the same item. Whatever the fractional part of the item is, needs to be the part of the item. Okay? They're the same. So hopefully you've had time to write those down. Again, if not, you're going to have access to this on Edmodo, and I'm sure that I'll review this with you. So let's go over this. We'll try to cruise through these. Also, 5/8 of the gnomes who lived in the magic forest had happy faces. If 840 gnomes had happy faces, how many gnomes lived in the magic forest? All right, so here we're given a fraction. And we're given 840 gnomes had happy faces. So then we're asked what? How many gnomes lived in the forest? That's asking for a total. So our fraction is the 5/8. I'm going to give myself just a little bit more room here. So 5/8 is the fraction. We're looking for the total number of gnomes that live in the magic forest. Now 5/8 represented the number that had happy faces. So our part, or our is, has to be the number of happy faces. Okay, and that is the number we're given. 840 have happy faces, so those go in those opposite locations. We've seen this before. 5/8 times a variable equals some number. We're going to put 840 over 1 and multiply by the reciprocal of 5/8, which is 8/5. 5 and 840 will reduce to 168, I think. And then 168 times 8, and I'm going to get my calculator to do that. If it'll come on here, 168 times 8 equals 1,344. In my arithmetic, I may have done that wrong. That doesn't seem like the right answer. So hang on just a second. Looks like it's right, times 8. Yeah, that looks right. And hopefully that's what the book has. Okay, number 2. On Monday, 2 4/5 times the acceptable number of rock badgers took refuge in the mountain caves. All right, so we have this fraction, 2 4/5 of the total number of rock badgers took refuge. So we have 2 4/5, and what that represents is the number that took refuge. Okay. If 640 was the acceptable number, how many rock badgers took refuge? So we are looking for how many took refuge. So that's where our variable is going on this one. And that means 640 would be your beginning number, your acceptable number. So there's already an idea that we can add to our acceptable number. It's what's allowed. The seating in the gym has an acceptable number. That's the total number of people that is legally allowed to be in there. Even though we could put more in it, that's what's the acceptable amount. And so that's what we have here, is 640 is the acceptable. Change your mixed number to an improper fraction. 14/5 times 640 over 1 is your result. Do some reducing. 5 and 640 is 128, and 128 times 14. Again, let me get my calculator going. 14 times 128 is 1792. Okay. So notice this part. If you can get that idea, you know that the same item has to be on opposite parts there to give you, to get it set up, then it makes it much easier. One more. When the fog lifted, 400 ghosts were spied skulking near the outskirts. If 240 ghosts were not spied, what fraction of the ghosts was not spied? Now we're asking for the number, the fraction that were not spied. Okay? So what fraction, and I don't know the amounts here yet, but I know that what fraction has to be the number not spied. Okay? What I'm given is 400 ghosts were spied, 240 were not spied, so the 240 has to go opposite that. Now the total, remember this item, our of is total, not just the automatically the other number. The other number is the number that were spied, 400. That's not the total number of ghosts. The total number of ghosts is the combination of those two items, which is 640. Okay, then you can divide both sides by 640 or multiply by the reciprocal of that, however you want to do it, and then reduce 3/8. If you want to check my arithmetic, you can do that. There you go. Whew. All right, one more lesson. It's already been about 18, almost 19 minutes, but I want to get all of this explained for you today, so it's not, we don't have to do it all when I get back. All right, what do we have here? Lesson 63. Oh, we're changing rates. Again, on Wednesday, if I'm here, hopefully I'll be here by then, we can go over these problems before we start the lesson, but we will be grading it. Anyway, we have changing rates. Prince Charming traveled 60 leagues in 2 days. Then he doubled his rate. How long would it take him to go 300 leagues at this new speed? So it's kind of a two-step problem here. It is a two-step problem. We're given 60 leagues in 2 days. The rate for that, remember, is distance over time. So the distance is 60 leagues, and that's an old school term. But 60 leagues in 2 days. If you reduce that, that's 30 leagues per day. Double that. Then he doubled that rate. Doubling means taking it times 2. So that is 60. So his rate is now 60. So how long would it take him to go? 300 leagues. Time, right? We're looking for a time. How long would it take him to travel that distance of 300? So time is equal to distance over rate. The new distance would be 300 divided by 60. This is the distance they want to know we can travel at the new rate, and that reduces to 5. So time equals 5 hours. All right, here we're talking about capping bottles, but it's still a rate and time thing. How many can we cap is we're looking for a speed, so to speak. So the machine could cap 50 bottles in 2 hours. So we're given a total. We want to know if the rate were to be tripled, so we want to find the rate, which is distance over time. 500 over 2 is 250 per hour. 250 caps per hour. Triple that means take it times 3. Triple in baseball is 3 bases. So your rate, your new rate, will now be 750 caps per hour. How many bottles could be capped in 10 hours? This is time. This is the rate that we'll be capping in that time. We're looking for how many could be capped. We're looking for that total. We're looking for distance, or I can't think of a better way to explain it other than we're doing the distance because it's rate times time. Even though it's not a distance, it's how many. It's the amount that we could accomplish. So let's see, capped. How many bottles could we cap? Let's use B. And then we'll put the rate of 750 times the time of 10. And that's 7,500 bottles could be capped in that amount of time. Okay, and I will. I am going to go over these again Wednesday if I'm here, because I'm going to show you another way you can look at these. I just don't want to confuse you yet with this stuff. All right, Raul ran 6 miles in 2 hours. Then he ran 20 miles in 4 hours. By how much did his rate increase? So we need to find the rates for each of these. So he ran, rate is distance over time. So distance of 6 miles divided by 2 hours is 3 miles per hour. And then he went 20 miles in 4 hours, 5 miles per hour. So we want to know how much it increased means how much did it get bigger by? He was going 3, now he's going 5, so that's a 2 mile per hour increase. Excuse me. Okay. That one's no big deal. That should be pretty easy. Again, do the best you can on these, and we will cover them later. I am going to assign problem sets 63, 1 through 30, and it's due Wednesday. I know I've taken up 25 minutes of your class time, but that should leave you about 20 minutes or so, and you have an early seminar tomorrow. So get to work on this. Good luck.